So with exponentials, here's basically what we're looking at for this thing. This is kind of, we're going to look at the equations and the functions first. We'll talk about the graphs in a second. So if it talks about an equation, you're going to have y equals b to the x power. Okay, now if you need like an actual, and here's where the numbers go in. So you're going to have y equals 2 to the x power. The big change for this one, here's the big change that we're looking at for this thing, is that everything else we've done before this, and y'all have to write this down. I'm just going to do this over here for quick. So this part of it, don't worry about writing this one down. Everything else we did x squared, or we did x to the third or x to the fourth or something like that, that we were doing those things. The big difference on this one is now the base is a number and x is in the exponent. So that's what makes it an exponential thing that we're doing, that x is in the exponent now. As we're going through this stuff. So it's not where x is the base. Now your base is a number and x is going to be in the exponent. If you're talking about functions, it's just f of x so maybe something like that. So when we're talking about exponentials, that's an equation, y equals b to the x or y equals 2 to the x power. For function, it's just f of x, as you're going through that thing. And again, the big difference is for these is that when we're talking about exponentials, x is in the exponent. Okay. Now here's where we'll try to speed this up a little bit. So what we're going to do is we're going to show you how this works. And this part now this is the thing that y'all may have to do one or two of these in the homework to kind of just to make sure everybody's okay plugging in numbers and working with the numbers, doing this. Test wise, y'all are not going to have to plot these like this, just like when we were graphing x squared. The very first time we made a list, we plugged in all these numbers. After we did that, when we started graphing x squared, we just had to know that, okay, it was a graph that looked something like this. And if it was, x minus 1 squared plus 3, we took that graph and moved it one space to the right, 3 spaces up, and then we drew it up here. So that's what we're going to kind of get to the point where when we're graphing these, we'll just do a quick sketch like this. The very first one, we're going to show you how we get the numbers, and then we'll kind of go with everything from there. Okay, so what we're going to do is over here on the side, just make an X. And make a chart. And then we'll put in the order pairs over here. So before we do any of the graphing, we're going to plug everything in over here and just kind of go through everything. Okay, and again, some of the homework, they may make you do this. You're not going to have to do it for every single problem because once we get past these, it's going to go a whole lot quicker. But just this very first part we have to do. Oh, wait, I'm sorry. Change these around. Those are supposed to be positive numbers at the top. Well, it doesn't matter. If you want to leave them that way, I meant for this to be negative down here. If you have a pen, you better have correction tape close by. There we go. Okay, if you plug in 3, y is 2 to the third power. 2 times 2 is 4. 4 times 2 is 8. There you go. So your first order pair would be at 3, 8. All right, so for the second one, 2 squared. 2 times 2 is? There we go. Easy money. All right, for the 1, 2 to the first power just means there's 1, 2. So the answer is just 2. All right, now here's the good question. It's been a little bit since we've done this one. What happens if you do 2 to the 0 power? All right, now here's what I'm going to do. Let me just kind of put this over here for a second. Then when we did this one, we had 2 to the third, that was 8. 2 squared was 4. 2 to the first power was 2. Okay, so how did we get, if we take away a power of 2, how did we get from 8 down to 4? Yeah, you divide by 2, right? So if you need to go up, you'd multiply by 2. If you need to go down, you would divide by 2, right? So if you know, when we go from 2 to the first up to here, we multiply by 2. So if we need to get down to this one, we keep dividing by 2. So with the next question, what is 2 divided by 2? It's 1, right? So 2 to the 0 power is 1. Now, and I used to think, that if it was 2 to the 0 power, and this is why it doesn't work. And this is where it's wrong. But I used to think 2 to the 0 power would be 0, right? And then it was like, all right, so what if we go up to 2 to the first power? It means we got to multiply by 2, right? So what is 0 times 2? To be 0, right? So if 2 to the 0 power is 0, then every power of 2 is going to be 0. So 2 squared would still be 0. But we know that 2 squared is 4 because it's 2 times 2. So 2 to the 0 doesn't work if it's equal to 0, because then every number, every multiple of 2 then becomes 0. So that's where we got to have it so the 0 power can't be 0. It's got to actually have something for it to work with there. Okay, so, and again, I used to be in that same boat. I used to think, oh, it's 2 to the 0 power. It's got to be 0. No, it's actually got to be something other than 0 to make this thing work. So 2 to the 0 power in that case is going to be 1. All right, if we do 2 to the negative 1, still going to do the same thing. We're still going to keep dividing it by 2. So if we take 1 and divide it by 2, that just makes it a fraction, just makes it 1/2. So if we do 2 to the negative 1, that's just going to be a half. And if we keep moving down, we're going to take 1/2, and we're going to divide it by 2 again. But if you do 1/2 divided by 2, remember that's where you can keep it, change it, and flip it. You can make it 1/2 times. So before we flip it, really it's 2 over 1. You make it a half times a half, which makes it a fourth. All right. Now, and here's the other thing I want you to kind of catch on this. Here's where we're going to try to make the connection with the negative numbers, is that if we needed, if the exponents are positive and negative, notice that the numbers are the same. Like 2 is 4, but if it's negative 2, if it's 2 to the negative 2 power, it's still 4. It's just 1 over that number. So when we did 2 to the first power, it was 2. When we did 2 to the negative first power, it was 1 over 2. So the shortcut for this one is, if we know that x to the third power is 8, 2 to the negative 3 power is going to be 1 over 8. So the only difference between a number to a positive exponent and a number to a negative exponent is the negative exponent just makes it a fraction, and it's 1 over that answer to get there. Okay, so there may be a couple of questions in the homework that you might have to do that just to make sure you can play around with exponents, because again, some of y'all, it's been a little bit since you've done some of that because we bounced around so much. So there will be a couple of problems where you're going to have to plug in some numbers. And again, that's where you get to use your calculators a little bit. And again, for these, if you do 2 to the negative third power, it's going to give it to you as a decimal number. So it's going to give you that. But again, that's where you can hit your second and your SD button. Where did it go? Right here. Hit your second and your PRB button that's there to change it to a fraction decimal. That'll change it back to 1 over 8. All right, so if we graph that, here's what the graph looks like. Okay, so just make an XY chart. We need more room this way because, again, we're going to 3/8. So if we go to 3/8, that would put us there. All right, and we got 2, 4. So over 2, up 4 to put us there. 1, 2 would put you there. 0, 1 would put you there. And then with the and then some people are like, what about the fractions? Well, we're just going to do the best guess you can with those because we don't have the numbers there. So if it's -1.5, you can just guess that that's somewhere about there. If you go to -2 1/4, again, that's going to be somewhere about there. And then the numbers are just going to keep getting closer and closer to 0. So if we go out here to 1/8, that's basically just sitting right on top of the 0. Okay. If you connect the dots, you get a graph that looks something like that. It's a nice little curve. It's like even my skateboarders out there, it's a skateboard ramp. Now the difference is, skateboard ramps, stop after a little bit. When we're doing exponential graphs, they don't stop. This thing keeps going forever. This way also keeps going forever out that way. Okay, so here's where we got to tie in a new point. We said that anything to the 0 power is 1. So like before when we were doing x squareds and all the other graphs, that we would always start back at 0, 0. If we were doing, absolute value of x, again, we started back at 0, 0. It was a V-shaped graph. That every graph we've done so far always started back at 0, 0. Well, for these graphs, when you plug in 0 to any of these exponential functions, you're always going to get 1. So for these, instead of starting everything at 0, 0, 0, 1 is going to be our new reference point. So that's one little thing you got to kind of put back for a little bit because, again, instead of starting at 0, 0 now, all these graphs really are going to start at 0, 1 for all the stuff that we're going to do. Okay, and now in every exponential graph that we do, as long as the base is bigger than 1, they're all going to look just like this. They're all going to have that look like it's a skateboard ramp where you would come up and then it's going to go off from here. You can also think about it being like planes that take off. Planes are going to start over here, and then they're going to eventually take off and fly. Now it's a little steeper than what a plane would do. Most time planes would go a little easier on that part, but that would be basically be like a real steep takeoff on a plane if you want to think about it that way. Okay. So if your base is, so this is kind of the new thing we've got here. So if your base is greater than 1, your basic shape will always look like this. Okay, and for that graph, when they talk about this thing being like it is, if the base is bigger than 1, this is what they call exponential growth. So if your base is greater than 1, the graph looks like this. They call that a exponential growth. All right, and then one new thing we added in on this one that you did back on the last test, on the last stuff we're doing is, you're actually going to have an asymptote here. So this one, you never get close to 0. So there's actually going to be an asymptote right here at 0. So when we did some asymptotes in the last section, last chapters thing we were going through, we're going to do that same thing. You're going to have a horizontal asymptote right here at y equals 0. Okay, so that's your cutoff line. You cannot, so if you're staying up here, you cannot get below that line if you're going through that part of it. All right, domain and range, throws back in there at you. Domain is negative infinity to infinity. That part never changes. Your range for this one, we're going to go from 0 to infinity because, again, that's where it starts there at 0 and heads up that way. This one, though, is going to change. It will change. Or we'll say it can change. Or, again, we could say it's y greater than 0. All right. And then now, just like when we graphed, quadratic equations back here when we were graphing these, most time we needed one or two key points. This one, again, 0, 1 is kind of our key point here because we know that point would be at 0, 1. And then the other point they may ask you to find on some of these is they may ask you to find like the y-intercept because we're going to start moving these graphs a little bit. So to find the y-intercept, you have to plug in x equals 0. Okay, so that's the one kind of big thing that we're looking at today. Here's the other little things that we'll throw at you because, again, it comes down to basically either we're going to have a growth or we're going to have, some people are saying it was decline, or you could have like a decay where instead of this thing growing and getting bigger, it's going to shrink or it's going to decline or decay and it's going to get smaller as we go through this thing. Okay, so there's the growth. That's the big one that we're looking at. The other one that we have, so we've got two types. We've got growth or decay. When you have decay, that means your base is going to be less than 1. Actually, it's going to be between 0 and 1. So y equals b to the x, where your base number is going to be between 0 and 1. So if it's some kind of fractional answer, if it's a half, if it's 2/3, if it's 0.5, 0.1, that kind of thing, they're going to call that decay because your base is greater than somewhere between 0 and 1. All right, and when you graph this one, it's just the opposite way, that instead of it getting bigger on the right-hand side, it gets smaller on the left-hand side. Still going to cross over at 0, 1. But we just take this graph we've got and we flip it around this way. So we're just flipping it side to side if we kind of want to think about it there. Okay, domain and range are going to stay the same because, again, we didn't move it any y'all, we just flipped it around. So just because we flip it around, domain and range can be the same. So anything growth, it's going to look like this. Anything decay is going to look like that. Okay, so when we do the transformations, here's where we're going to take these graphs we've got and we're going to move them up, down, left, right, just like with x squared. We would move them up and down and left and right on these. So for this part of it, we're going to do basically the same thing here. So if you add some number, or again, you could subtract it. So we'll say if you add or subtract some constant, some number on the inside, and this time it's inside the exponent, because before it was always parentheses or absolute value or whatever it was we were working with. This time it's inside the exponent. So now we've got this number in the exponent. And you'll be able to see it because if it's in the exponent, it'll be a small number. If it's outside the exponent, it'll be a bigger number. But if you add or subtract some constant inside the exponent, it moves the graph opposite horizontally. So again, left to right in the opposite direction you think it's going to go. So anything, and it's still the same thing like when we did x squared, when we're graphing quadratics, it's still the same thing. If it was in the parentheses, it went opposite direction, left and right. This time, if it's in the exponent, it moves it opposite direction, left and right. So it's still the same movement, same direction. It's just a new graph that we're looking at. All right, and then again, if they put on the outside of parentheses, and this is where you can see it a little bit better because if it's inside the parentheses, it's a smaller number. If it's on the outside of parentheses, it's a bigger number. So I'm not going to try to trick you on the test. This one should be really easy to see if it's inside or outside because there's no need of trying to trick anybody on this thing. So if you add or subtract a constant on the outside, so if you're on the outside of the exponent, inside is going to go horizontal in the opposite direction. Anything on the outside is going to move it in the vertical direction. Okay, so again, inside is horizontal, opposite direction. Anything on the outside, it's vertical in the normal direction. Okay, and then a couple of little details that throw at you too. A negative in front of the base. So if you're talking about that, and what that would look like is, for that part is if you have something like that, if you have negative 2x. Sorry, hang on. Negative 2 to the x power. There we go. So if you have something like that where the negative is out in front of the number, that reflects it over the x-axis. So if they put a negative out in front of the base, that's going to reflect it over the x-axis because again, it's on the outside, so it's got to go vertical. And if you're multiplying it by a number, basically you got something by a number. If you do one that's greater than 1, so we do a number, let's just call it n. So if that number is greater than 1, it stretches. If that number is less than 1, it shrinks or compresses or whatever how you want to say it there. We'll say it, Well, let's just say compresses. I think compress is the word they use. Okay, but either way you go in that case, it's a dilation. Okay, so that's the big things that we're kind of looking at. That's the main stuff we got to have. So the mask of the graph y equals 3 to the x plus 4, or 3 to the x minus 4 plus 1. Okay, in almost every single question, they're going to ask you, is it growth or is it decay? And that part, hopefully everybody should be okay getting those parts and pieces with it. All right, now here's how easy the growth or decay should be. What number is attached to the x? What number is underneath the x? You got 3 to the x power, right? So in that case, 3 is your base. So if the base equals 3, and that's where, again, if the base is bigger than 1, it's growth. If that base is less than 1, it's decay. So for that problem, 3 to the x minus 4 plus 1 is a growth. All right, now here's how easy the graph should be. So here's where you need to kind of know the stuff we're talking about. This negative 4 that's up here, which way does that move it? 4 spaces to the... Yep. So on the inside, so we're going to go opposite horizontal. So if it's minus 4, we think it's 3 to the left, but it's actually going to go opposite. We're going to go, or sorry, 4. We're going to go 4 to the right. And this 1 that's on the outside, so it's 1. All right, now here's the big difference when you're graphing these. We almost always we were starting back at 0, 0. But again, for these, if we were graphing just 3 to the x power without any of the other stuff back behind it here, that would be one that would start crossing over at, it would look like that. What would cross over here at 0, 1. So we're going to move everything from here. So we're going to go 4, 1, 2, 3, 4 spaces to the right. There's our 1 space up. So now instead of crossing over here, we're going to move it 4 spaces to the right and 1 space up and put it right there. So again, we're starting here and not at 0, 0. So we're going to start here, go 1, 2, 3, 4 over 1 there. And then we're going to draw that graph. So it looks like that. And that's what I'm looking for. So if we're doing these on the test and you actually have to sketch a quick graph, that's the one thing I'm looking for. I'm looking for, do you have this point that's here and do you have the basic shape of it? And if they ask you to draw an asymptote, which I don't think they would, but if they did ask you to draw an asymptote because you moved everything up 1, it basically would, you'd have an asymptote that would be right there. Because we did have it at 0. Since we scooted everything up 1, well, now this cutoff line puts it up right there. So now we're cutting everything off at 1. Only if you've got a number on the outside. So like if this had been just 3 to x minus 4, we would have just scooted over 4 and it would have not moved any up or down. It would just stay right on top of the 0. Okay, so now here's what's going to happen. If you've got this number on the outside, whatever that number is, the domain's always negative infinity to infinity. Again, that part never changes. That basically whatever this outside number is that's here, that's going to tell you where you're going to start, and then we're going to go from there up to infinity. So if there's not a number out here, it's at 0. If you've got a number outside the exponent here, that's basically where you're going to start your range, because you screw everything up one space, so it starts at +1. Or again, you could say that it's that, or you could just say it's y is greater than 1, because it starts off here close to 1 and it takes off and goes up.